SB7. So this is improving accuracy with the gauge. Because with FT you have one accuracy, but we want better. So we must have some kind of formula so we can say that more exactly that this is the position. So if we look at the FFT, this is fast Fourier transformation. This is more or less converting our tank signal, which is like a lot of frequencies, into time domain, saying that it's this frequency and with this signal strength or amplitude. That's what it will do more or less. This is a very, very common type of way of analyzing frequencies. Our oscilloscopes, for example, are using this method. So we can track up to 10 echoes, and the basic accuracy we get only using FFT is plus minus 3 millimeters. So correct gauge is not good. These FFT echoes we also put into what we call echo logics. So we look at each echo we find and we categorize them and give them points. So if we look at this FFT signal, it could typically look like this. So we have the tank, we send the signal into the tank, and the return signal we get looks like this. And as you can see, it's very hard to understand which is the frequency is the surface. Because you have also noise and maybe disturbing objects. They also give you a frequency. So it looks like a bad radio channel with nothing, no transmission. So then you find it correct. So by doing the FFT analysis, you get like a time domain. You can say that this is corresponding to a distance, well, I say a time, but it's actually a frequency that we say. So the higher the frequency is, the further away will be. It means in our case that the lower the level is, or the longer distance from the radar, the higher frequency we will have. So this is then changing. And here we see we have one peak which is more dominating than others. And that most likely we hope it's our level. The things, what you see here, we can say this is noise. We have to set some kind of thresholds and eliminate those later. So this is FFT. We have this fast filter to improve our accuracy. It's just an algorithm, mathematical, for in the beginning when Pro Gauge came, it was no need to have very high accurate readings sometimes maybe. Then you can, by not activating this function, you have a cheaper gauge. Maybe you didn't have any disturbing objects, echo fixer, one module also. If you say, I have no disturbing objects, okay, you can don't activate this function. Cheaper gauge. MET, multiple echo tracking also, if you say, no, only one echo, not many. So you say, don't say, okay, cheaper gauge. Maybe you don't have an explosion-proof tank. Okay. No, let's say explosion-proof certificate is cheaper gauge. So that comes from the Pro Gauge. So you can activate later if you wish these modules, and then you buy or pay the money. So fast module is always on in Rex and the Pro Gauge for inventory tanking. Of course, this if the fast module is increasing the accuracy from plus minus 3 millimeters to plus minus 0.5, it means that we can only use this formula when the level is very stable. The level must be like a mirror. if you have waves, it goes like this. So it's no use to try to look for the level within 0.5 millimeter. So then we use only basic FFT. And when then the conditions are stable again, then we can focus more. So it's automatic, it's nothing you have to think about. But this is how it works. This pulse filter is more like, once we have found this one, then we apply another filter around the peak we have found. And this way we can increase the accuracy of that level. That's the theory of the pulse filter. Okay, you have the gauge, you have the power supply, and then when you plug it in, like this, then the gauge will stop. What happens? You already see we have a boot software, checking in the hardware. You say that application is okay. Then it will of course use the FFT, transmit, and see is there any echoes. And then it maybe gets many echoes. So what he has to do now, the firmware, is that he must identify all echoes. And then he will create a list of all the echoes he will find, put this in this echo validator, you can say. And for each echo, he will look at the quality of this echo and then give, let's say, a number of points. It's like if you're in a swimming competition, with the ladies jumping down to the pool with a certain, and the judge sit there, 3 points, bad jump. And then it's like, oh, 10 points, very good jump. Same thing here. Depending on the quality of the echo, it will get higher rating. Same thing. That is the logic behind picking the echo which is the correct level. So it more or less sets the winner as the surface. Also, it will put a tracking window around these surfaces. The tracking echo will be called closed list. This name you can find in the holding registers. Maybe you already found it. Okay. Who found it? Have you found closed list? You found? Okay. Do you remember the value?
61.
YH 800 millimeters. It can be, if you set it 800. Default value is that much. Half meter. 500 millimeters. That is the default value. It's closest. Then, of course, we have the fast filter to get higher accuracy if the level is very stable. Okay, so the gauge found many echoes, maybe in your opinion too many echoes. So then you can sort of ask yourself, how can I improve the situation for the gauge? I mean, it's your input, maybe for the gauge. Say that, okay, we have to adjust a little bit. So what can you adjust? Well, we can look at some basic things. If you have looked at the tank scan, you have, for example, the blue line, the threshold. This one here. It's black here, but it's blue in setup. This one you can change. If you feel that if this threshold was maybe too low here, and you have some noise, you can lift up the threshold because you see the peak is very good. We can increase the threshold. This way, eliminate the bad peaks. So it means that all signals must be higher than this black line. Everything which is below here is thrown, not valid, not accepted. The other thing you can do is that you can create your own breakpoints, like a customized noise table, or ATP, or in 5400 it's called measurement blur. But it has many points. This one has only 10 breakpoints, which you can adjust on 10. So here, it means somebody has created an ATP table, and in this case, that's the red line here. In this case, it means all echoes above this black, and then above the red line will be approved, as we see. So this area in here, nothing will be approved as a level. Then we have another thing which you cannot see or touch or anything like that. It's there. It's like an invisible function. And this is called what we call a C4 threshold, a kind of floating amplitude. C4 means continuous false alarm ratio. Or in other words, we call it signal to noise ratio, SNR. This means how good is the signal compared to noise. So what is the difference between top of the signal and top of the noise? That is the signal to noise ratio. That one here. So what we do here is that for each echo, we look, if we have a peak here, right, and then you have something like this. So we look at, from that center point, we look a little bit here, and then we look at a little bit here. So in this area, the noise that you have, okay, here is nothing, but here you have something. And then that point here, so this is the default value for this expression. How good is the signal to noise ratio? It must be minimum 10 decibels. If you're aware of how decibel works, then you maybe get if you're used to use the abbreviation called millivolts as we use for the threshold and our signal, suddenly we have an expression called decibels. So okay, just accept it. When it comes to tank gauging and high accuracy installations or RX, that 10 decibel is usually quite okay. There's no need to change it to anything like that. I have only changed that in very, very tough applications in solid silos or anything like that, for process applications. Otherwise, I have left that parameter. I've never touched it. There's a lot of parameters which are very good today by default, because we have checked by over time, so the default settings that we have is very good. Okay, echo tracking. That's maybe an interesting phenomenon. That if the level is stable and sitting there, it's very easy for the gauge. But if the level starts moving up and down, you can have different scenarios. You can have different movement. It moves fast or slow or something like that. That can be an interesting thing. What should the gauge do if the level starts moving? Okay, in order to track an echo, the gauge must be able to recognize echo between consecutive measures, meaning that if the level is stable, it means every measurement is on this point. But if the level starts moving, then these measurements will be different in position. And then we have to tell the gauge how much change can you accept, if it's good or bad. So then we have our tracking window, the red line here. It means that if we are measuring here and the level, sort of the signal processing suddenly detects, oh, we have one echo here. So from one measurement to the next, it's suddenly here. It means that we are outside this range. It means we will not accept. So it means that measurement will be thrown away, not used, and then we take the next measurement. Maybe that was some other echoes, so we will not use that. So we have to sort of keep the movement within certain limits to accept the echo. Now I'm going to wipe this one, and this will maybe very good for you to know how the gauge is reacting in different situations. So, okay, we start here. It's exactly the same picture here. So we have our trend. This is time, and this is you can say level. Here we have our good echo. And I will take another pen. I will take the red line here. This is our tracking window. And we have the scenario here between the consecutive measurements. From this point here, then the level will move to that point. So what will happen with this one? Well, we have our tracking window. It means that it's within our limits here. The gauge will then just move to that point. And then our tracking window will of course move to that point also. And we have, let's say, a normal level. Nothing spectacular. The gauge will handle that situation. Then we have the next scenario. I mean, if we talk about half a meter, it's quite a big jump, but we can theoretically analyze what could happen. We can take this one. So from this point here, then the level will suddenly be here. So what happens? Well, the gauge, he will sort of detect that from this point here, don't find it anymore. So it's just like somebody closed the light or something. No echo anymore. So what the gauge is doing is starting a clock. This point here, we call this time 0. It means that this echo is going like this, and these windows are just staying on the last known position. And this is continuing. So, how long time should we continue like this? Forever? Or should we say stop and we have to stop the clock? Have you heard about echo timeout?
30 minutes. 30.
So, here, call it ET. Not a movie, if you've seen it, but echo timeout. And this is default
30 seconds.
30 seconds in all gauges. So when it comes here, the echo will continue, and this will do something here. I don't have a stable hand today, but this time anyway here, we have to do something. What shall we do?
Hold the last value.
Hmm?
No, slush. Slush.
Such.
Okay, I will give you a small hint.
Bring echo within the code systems.
We have two options. We can do something we call a fast search, or we can use a slow search. Fast search, increase. Yeah. If we can assume that we use a fast search here. What happens is that happens. Our window will automatically expand suddenly to minimum and maximum range, what is possible to measure. So we search full range immediately. And then what happens is that after this, it will update itself from this point when it finds the echo. It takes some time to find it, but theoretically it will do it like this when it finds the echo. So we immediately look for the whole range, and then it will find the echo. And then we again put the tracking window.
So this one immediately look at the full range or wider range?
Full range.
Full range.
Full range.
Within the
What is minimum and maximum possible?
within the 30-second search,
After
if
the
out
30
of the out of the FFT, it will increases the range a certain seconds and then find the echo where,
Yeah,
and
remember.
then it maintains again the.
Remember, we have a list of candidates of possible echoes already detected. So if you look in the previous slide here, we have like some kind of background check of all the other echoes. Because we can have up to 10 echoes in our back pocket. So this is not good. This is the good one. So this is good with FFT. We can have several frequencies, several positions. Okay, if we go back here and say, no, we didn't use the fast search. We didn't do this. We used the slow search. How does that work? Well, from the original position here, we say we start doing like this. This is our slow search. It means from that point we slowly start increasing the area. So it means in this case, when we have a fast search, we immediately find it more or less. But here, we only find it after a certain time. It's when we have reached or expand the window to that point where the echo is. So in this case, it will take some time before we find it. And of course, it depends on this one. Is it like this? The K-factor. How fast shall we expand this slow search window? This here, this is called search speed. You can change also that. Okay, so this is something you can also you can do to help the gauge to make the right decision. Of course, in tank gauging, our storage tank, the level is very slow movement. So in this case, you can maybe use this slow search. No big deal. process conditions, you maybe need faster reactions and so on. Okay, now I said we have a possibility for 10 echoes, which we can track. We don't want 10 echoes, we have to track. In 10 kg, high accuracy measurement, we only want one. Only one echo. We don't want two, not three, only one. Because if you have 2 or 3 echoes, it means you have some disturbing objects in the tank. Disturbing objects means not accurate measurement. And we want accurate measurement, not this disturbing visual cause.
So if the disturbing object is kept under the ATP, will we consider lesser accuracy?
Always. The situation you should have is, well, actually just one echo. Even if you use the ATP on this one or that one, the energy is still present. Energy is inside. You have it. So when this one comes and moves closer to that one, it means those two echoes, they start competing. And it means when you have 2 echoes, I usually show a nice slide what happens with the trend. I will show you. Now if this is a, let's say, this is a disturbing object, and this is our level, when it's going like this is the ideal trend, filling the tank, and this is the position for our disturbing object. I mean, this is always the position of the disturbing object. Okay. We can, I just go forward here. As it says on the point here. If we can remove them, we can always put this in the software. So the gauge knows there is a fixed position which will give you problems. So it means that we will say that pay attention to this place position here. But still the energy is present. Now it depends on how strong is this signal and how strong is this signal. The relationship. Is this very small? Maybe let's say we take one figure of 500 millivolts, and then the signal from the surface is 2000. It means the surface is very strong and the echo is not so strong. So it means this is more powerful, right? But if they are close, then they are competing with each other. And what happens with the trend then, if they are, let's say, 50-50? This is what you will see. That will be the trend. I should have maybe showed you with a red pen instead. Without the disturbance, it would be a straight line. But with this, when its level is passing the fixed object, it means those two echoes are competing. The level will be very unstable. And you can see this on the trends also. And the customer who has a very high unstable surface when they are filling the tank, they don't like it. They want to see a straight line. If they have a fixed pump rate, they want to see a stable rise, not level start jumping up and down. So that is the effect you will get from disturbing objects. So we can handle that. Reason for having a disturbing object could be that maybe when we installed the radar, that was the only place we put the radar. Just one existing manhole. They don't want to weld them, and they don't want to remove any objects, anything like that. So we say, okay, fine. We can put the radar, we can measure, there will not be any problems, but the accuracy will be less because of this fixed object which will give us a disturbing object. So we have to point out those things. And then what we can do, we just sort of register that echo in the gauge memory, saying that pay attention on this position, there is a fixed disturbance, you must handle this. Gauge will do that, no problems. It will not stay, let's say, lock on that fixed object, but it will continue track, filling, emptying, no problems, but the level will be unstable. The important thing is that when you tell the radar where this disturbing object is, that you should not have any liquid above where you have the disturbance, because then you cannot say, or the radar cannot see exactly where it is. The liquid must be under the point. Very important. Okay, let's have a look at what is REX optimized for from factory. It's optimized for flat tank voltage. It means that it is expecting a signal from the empty tank when it's empty. When it's not liquid, it will get the bottom signal. If we compare probe, what is it optimized for? Well, it depends on you. What you have told the gauge, that okay, you are sitting now on this tank and the bottom looks like this. So you decide what the gauge will be optimized for. Then empty tank handlings, I mean, what shall the gauge do when the tank is empty? That's also possible to sort of select in the Pro gauge and also in 5900, as you will see later on. REX doesn't have this feature. Maybe have discovered it already. You can optimize the gauge a little bit when it comes to the tank environment. If you have turbulent surface, let's say rapid level change and other things like that. So you can just check in the boxes here. But you can do it only for the Pro gauge. The REX doesn't have this nice window where you can put in the checkboxes. Here you maybe manually have to go and set the registers. So it means maybe changing 3-4 holding registers to achieve the same thing. When you do this, when you check in turbulent surface, it means this checkbox will do some changes here. These are the values that will be changed. You just mark turbulent surface or anything like that. So it means you can manually, unchecking that one, then change the value itself. We have our echo time out here. We have the close distance, surge speed, and so on. Those you can change manually yourself. This window is available in Pro, but not in REX. Here you have to go into the holding registers where you find this parameter.